Hello everyone. Thank you for joining us today for this deep dive session on MySQL databases on AWS. My name is Chayan Biswas. I'm a senior product manager with Amazon Web Services in the relational database services space. With me today is Steve Abraham, who is a principal specialist solution architect also within the RDS space. A few points of logistics before we move on. We just have about 30 to 40 minutes, and it's a deep dive session, so there's a lot of ground to cover. For Q&A, you can use the Q&A panel onto the right-hand side of your screen to type in your questions. We have a few colleagues of ours who are helping us answer those questions as we go along, so feel free. So let's get rolling here. So what can you expect from this session? We'll briefly talk about RDS and then dive into MySQL databases, specifics of those. It is, of course, it's a deep dive session, so we'll also be talking about best practices, how you can optimize usage of your MySQL databases, and share tips on performance tuning. Of course, all this is not worth much unless you can migrate your databases, either the ones you are running on your own in your data centers or self-managing on EC2. So we have a demo for a migration that you can perform. Starting off with, first of all, what MySQL offerings are available to you on RDS. So of course, there's MySQL. It's one of the most popular open source database engines available to you today, and we offer the community edition of MySQL. Additionally, MariaDB is a fully MySQL compatible community developed engine, which was forked from MySQL and is promised to remain open all through. And then we have Aurora. Aurora is a completely reimagined database engine for the cloud. It offers you the performance and availability of commercial databases at the price point and flexibility of open source databases. For today's session, because Aurora itself involves so many great innovations, it calls for its own deep dive session. So we'll not be able to get into the depths of that. So the primary focus would remain around MySQL and MariaDB, although we'll be touching upon Aurora a few times. There are some great resources on Aurora. If you want to take a look at that, you can look them up on YouTube. All right. So first of all, let's get started with why would you want to use RDS? So when we look at the typical work performed by a database practitioner, someone operating and building databases, what we see is a large portion of your time goes into installation of the operating system, installing the database software itself, managing patches, upgrades, taking backups, restoring backups, ensuring that your uptime stays there. And then, of course, there's licensing, training, and documentation that's also required to be maintained by you if you're operating. And that leaves you very little time for optimizing your database schema, optimizing your database queries or applications, things that are valuable to your end customers. And that's where RDS comes in. So RDS takes away all this undifferentiated heavy lifting from you and manages it for you so that you can focus on what matters for your customers, which is optimizing your database, your schema, and application. So what are some of the key features offered by RDS? High availability is one of the key concepts that you must be taking care of when you're developing your application. And by design, RDS makes this available to you. So you have access to multiple AZ deployments, availability zone deployments, which makes your databases more fault tolerant, and you have failover capabilities. We'll dive deeper into this in the next slide into the key features as we come along. Another area we see customers find a lot of value is with RDS as the backups and time recovery options that are provided by RDS. So you have the option of rolling back your database to any point in time within a given window or period. And all these backups are managed by RDS. So you don't have to schedule or monitor these backups. Scalability is another area where quite a few times we have seen customers needing to update their either storage or compute resources. And RDS makes this really simple. With just a few clicks, you can add more storage or compute capacity to your databases. So the entire process of like taking down your database, building a new one, and then reprovisioning that, enabling that, that downtime comes down, reduces to a significant extent. You also potentially want your databases to be highly secure, and possibly are looking at compliance regimes such as HIPAA, PCI, what have you. So our engines are certified for quite a few of these. We will see the details there. And of course, RDS does not operate in a silo. It's an AWS service, so there are great integrations with CloudWatch, S3, Lambda, where you can leverage these services for your workloads. There's a lot more to discuss. So let's get started with this. So high availability, it's one of the key concerns that customers focus on when they're looking at building their applications. And the way it works in RDS is that you have the ability to deploy your database in an MAZ or multi-AZ setup. So what do we mean by an availability zone? You can think of an availability zone as an isolated location or a combination of data centers which have their own dedicated utility networking so that they are tolerant of failures from in other availability zones. What we do is we maintain a hot copy or a replica of your master database in a way that it's synchronously replicated whenever you're making updates or changes to your primary database. In an event that your primary database becomes unreachable, degrades, or fails, RDS automatically detects this, and typically within minutes is able to bring your hot replica over as the primary without any changes to the endpoint. So it's transparent to the applications that are connecting to the database. And this happens because we are synchronously replicating. There's no loss of data associated with this. Even beyond that, when we look at disaster recovery situations, broader scale events where you potentially lose access to entire regions, AWS regions. So consider an example of, let's say, a hurricane barreling down the East Coast, and let's say you're running your database out of US East Virginia. Now, you may want to then have the ability to replicate that database over to another region. In this case, what you can do is you can replicate over to US West Oregon and use that database as a warm copy of your production DB. And in an event, if you lose connectivity with your master database, you can pull up one of these read replicas and make them the master and start pointing your applications there. Typically, we see customers use CloudFormation templates to quickly spin up application stacks within that region, in this case, US West Oregon, and start running that application. Another use case customers use read replicas for read scaling. So if you have a read-heavy workload, in that case, what you can do is you can provision multiple read replicas, and that reduces the burden on your master to perform these read tasks, and that read scaling can be then scaled out to multiple instances. Additionally, you of course can locate these read replicas in locations where you have applications closer to the region and are performing only read operations. In that case, you're co-located with that read replica and you have faster access. And finally, there could be situations where you want to move your data over to another region and start another application stack there. In that case, also you can use a read replica, copy over the data, disconnect, make that the master, have your application talk to it. We also support encrypted read replicas. So if you have turned on encryption in your master DB, that encryption carries forward to your read replicas too. Another key consideration while operating any performant database is to be able to have reliable backups and snapshots taken for those databases. So let's look at what it means in the RDS parlance. So for MariaDB and MySQL, you can schedule daily volume backups. So you can select when you want the backups to be taken. In addition to these backups, RDS also continuously takes snapshots of your change logs every 5 minutes. So you have the ability to dial back to any 5-minute window within a 35-day retention period. So you get to choose how long you want to retain these backups. It's taken from the standby in case of a multi-AZ deployment, so that there's no performance impact to your master when these backups are taken. In case of Aurora, it's slightly different. Aurora continuously backs up your database, so there's no scheduling required, and you can go back to any point in time within that 35-day period. And also, there's no performance impact with the way Aurora operates its backups. Okay. We briefly talked about scaling when I was discussing the RDS key capabilities and features. Now, let's imagine a situation where you have a database running, you provisioned it with sufficient compute capacity at the point, but then suddenly your website or application has become really popular, and now you need more compute resources devoted to it. The operation is pretty straightforward. What you have to do is go on to the RDS management console, and as you see in the screenshot, you simply select the instance type or class you want to go up to. And you can also change the allocated storage in this step if you wish to, and apply these changes immediately. So right away, you can scale up with a click of a button your compute and storage. Do keep in mind it could result in a little bit of downtime as the volume as the new instance is spun up, but you don't have to bother about building another database and cutting over to that database and pointing your applications to a new database. This just happens with one click, and all your settings such as security groups, encryption, etc., are all retained. Security is also very important, and RDS offers you all the capabilities that you would get with typical EC2 deployment too. So you have VPCs or virtual private cloud, which in a sense is an isolated network for your workloads. You get to control access to it, so who gets access into it and out of it. You can define those parameters. Additionally, RDS allows you to define security groups for your DB instances. So you can define what kind of traffic is allowed in. And as a best practice, typically you would want your databases to be accessed only by your applications. In that case, make sure you set up the security group ingress rule to allow TCP traffic to port, let's say 3306 in case of MySQL, from the specific IP address range you want your applications to be connecting with from. This another very useful integration that exists for RDS and Aurora is with AWS Identity and Access Management. So you can use your IAM users and roles for provisioning access to your database users within MySQL, MariaDB, and Aurora. What it allows you to do is you can use the same credentials that are used for providing access to AWS resources also for your database access. You simply associate your IAM users or roles to database users you have created, and the credentials are then managed by IAM and stored in IAM. I do want to touch upon a little bit on how encryption works and how KMS helps you with this encryption setup. Now, KMS or Key Management Service allows you to create a master key and just maintain and manage that. You can rotate it. But the benefit in terms of using KMS for RDS, which is the default, is that you don't have to think about managing hundreds or thousands of data keys that are used for encryption in your databases. So let's say when your application is either inserting data into your databases or requesting data from your databases, RDS would use your customer master key and generate a data key. That data key is then used to encrypt the data or decrypt the data. And then the data key itself is encrypted using your master key and stored in KMS. So you don't have to bother about these individual data keys. All you need to care about is the master key. Compliance is also of a primary concern or focus for many customers. Many times you may want to get HIPAA compliance, SOC compliance, PCI, and many more. So many of our engines are certified for a set of these compliance regimes. There's a list out there. I'm not going to read out each and every one of those. I'll let you take a quick look at it. One of the new compliance certifications we recently announced for MariaDB is for HIPAA BAA. So let's look at some of the engine specifics and what is offered through RDS for this. So the first one here is MySQL. As I mentioned, it's one of the most popular open source databases available out there today. We support three versions of the community edition: 5.5, 5.6, and 5.7. MySQL supports multiple storage engines. The support for RDS in RDS is for InnoDB and MySQL. What it also means is that you have drop-in compatibility. If you are running applications that use MySQL either with InnoDB or MyASM storage engines, you can just point those applications to an RDS MySQL database and they should work as is. You want to highlight some key capabilities of version 5.7, and one of them, which is very popular amongst our customers, is JSON support. So MySQL 5.7 supports native support for JSON documents. They are stored in an optimized binary format. What it enables for you is that you get native documentation validation, document validation built in. In addition to that, you get very efficient access to your documents and array elements within your documents because it's stored in a binary format. You can also improve the performance of your queries by setting up indexes with virtual columns within your JSON document data. So that speeds up access to your data within JSON blobs. And finally, there's the convenience of course, using document queries in combination with SQL queries. So you get the best of both worlds. There are also key query optimizer improvements that have been done essentially around the cost model. So you get to benefit from improved where condition and join order operations. You can also set your own cost constraints. It's configurable with 5.7. And additionally, merging and in-queries are also optimized within the query optimizer. GIS extensions allow you, with the implementation of GIS extensions in 5.7, you get better ability to handle geospatial data within your databases. Spatial indexing is also available, so you can set up indexes for your spatial data. So that speeds up significantly access to spatial columns. And when we think about replication, MySQL supports multi-threaded replication, but it has been improved significantly again for 5.7. With the row replication format, which is now much faster than the statement replication format, which was being used before. And additionally, you can resize your buffer pool dynamically, so you don't just have to do it when you start your database or need to restart the database for this. You can do it as you run it. Version 8.0 is not yet GA. Next up is MariaDB. Now, MariaDB is a community-developed edition, as promised to remain open, and it was forked from MySQL. We support versions 10.0 and 10.1. When we compare to MySQL, it's pretty much the same offering in terms of the instances that you get access to, regions, pricing, as well as the free tier. So you get access to the same free tier that is available for MySQL. Few differences when you compare MySQL with MariaDB is that extra DB storage that replaces InnoDB, and this area storage engine also available for you. Thread pooling is offered as part of the community edition, so you get to benefit from that. And GTID, or global transaction IDs, allow you to track transactions across multiple database instances that are replicated so that you can compare your transactions easily. In version 10.1, there are a few additional features such as page compression for ExtraDB, which is slightly different from the compressed storage format provided by InnoDB. You only get compressed files within the buffer pool, which is different from InnoDB storage, where you could have both compressed and uncompressed. So this improves performance. Similarly, there are improvements to data scrubbing and defragmentation that are available to you with version 10.1. You also have the ability to turn on optimistic mode in case of parallel replication, which allows you to commit parallel transactions on multiple slave databases while maintaining the same transaction semantics as you would expect without optimistic mode as well. And then there are improvements for order by queries where you have the smarts built in that performs that makes it perform better than MySQL. Version 10.2 is coming soon. I touched upon briefly on Amazon Aurora, and there's one point that I would want to emphasize if it's a key takeaway that you want to take away from this slide, is that Aurora is designed to provide you the performance and availability of commercial databases at the simplicity and price point of open source databases. It's completely reimagined for the cloud, so it uses a really innovative, scaled out distributed multi-tenant storage architecture, wherein your data gets copied over 6 times in 3 availability zones. So you get high availability built in. Additionally, there are integrations that exist, so you can use Lambda functions from your stored procedures and triggers. You can also load data from and select into S3 buckets for long-term storage. And IAM role for database access control, much the same way I described before, is available with Amazon Aurora. We are working on MySQL 5.7 compatibility. It's coming soon. Few other things I wanted to cover in terms of what customers typically ask for is auditing. Many times customers desire to know who accessed their database, what happened to their database, especially let's say if you're storing PII, personally identifiable information in your database, you might want to know who gets access to it. So for that, you can turn on the MariaDB audit plugin for both MariaDB and MySQL. The information captured in these audit logs generated by the plugin includes connection information, even failed connect. So additionally, you get clear text query that was performed on your database collected, and additionally, all the tables that were impacted by these queries are also recorded. You get to pick and choose which users you want to report on. So if there's a certain set that you want to exclude, you can do that. That's also possible. Today we support this plugin for the listed down versions there. I'm not going to read through each one of those in the interest of time. And this is turned on with an option group on your RDS instance. With Aurora, you enable advanced auditing with DB cluster parameter groups. There's, of course, a performance penalty for this. You may want to wisely choose what kind of activity do you precisely want to record here. Another key capability we launched a few months back was the ability to start and stop instances. So there are situations where you may not want your database to be always running. So for example, if you have a development team building an application, you are only working 5 days a week, don't want the database running over Saturday or Sunday, weekends. Or let's say you're running test workloads, which you do only a couple of days a week, you could make use of this capability, wherein you only pay for storage, backups, and snapshots, but you don't pay for any compute capacity once you stop your DB instance. The configuration for your database is retained, the endpoint remains the same, parameter group options, everything remains the same. So you get the option of just turning off and saving costs on the compute capacity. RDS will automatically turn on your database after 7 days if you don't turn it back on. So those are the pieces I wanted to cover in terms of the database engines that we offer with respect to MySQL and RDS, and common features that are available in RDS. Of course, we also want to look at the best practices, and for that, I'll hand over to Steve, who will run us through this. So, Steve, off to you.
All right, thanks, Chayan. We're going to continue on talking about some of the best practices when it comes to running MySQL and MariaDB in Amazon RDS. So one of the things that we want to talk about is multi-AZ configurations. This can be really useful if you're looking to maximize availability for your applications, both for planned and unplanned events. Things like resizing instances can be handled with multi-AZ to minimize impact and to maintain your highest availability. And the same thing if there were to be some sort of an availability zone issue where you needed a failover. The cons to this, of course, would be there's an additional hourly charge for having the additional instance that's online and running and is essentially your hot spare. And there could be some potential latency to that slave as well in the other AZ. Another best practice that we recommend is leveraging read replicas. Read replicas allow you to scale your reads. So if you have a read-heavy workload, you can handle those requests without having to impact your writer at all, and you can scale those reads up dramatically. This can also be very useful in the event of disaster recovery. As Chayan was talking about earlier, if you needed to fail over to a different region altogether, read replicas are a great way to provide that disaster recovery. And it's also great for upgrades as well. The considerations that you want to take into account are that your application needs to be able to handle asynchronous behavior. And by that I mean the read replicas will frequently be, at least a few seconds behind, depending on what your workload looks like. And so your application should understand that and should be programmed accordingly. Another thing that we recommend is to leverage enhanced monitoring. Enhanced monitoring is a feature that we released for all of the RDS engines a few months ago, and it allows you to view a number of additional metrics for tuning and troubleshooting your RDS instances. There is a nominal CloudWatch Logs charge for enabling this feature, but overall it's something that will really help you to fine-tune and tweak the performance of your instances. What we're looking at right here is a sampling, an example of some of these enhanced monitoring metrics. You can see that we have over 50 system and OS metrics that can be scheduled down to between 1 and 60 seconds in granularity as well, and can integrate with third-party tools. With RDS, since it's a managed service, the operating system is controlled by Amazon, and we also administer the database engine itself. And so to that point, we don't allow sys user privileges. Instead, we allow for certain operations the ability to leverage these stored procedures. For example, RDS kill can be used to terminate a connection. RDS kill query to terminate a query. You can also do things like stop and start replication, which we'll see a little bit later in our demo that we're going to do. And you can also move along, skip a replication error, or change the master log position on a replica in the case of bin log replication. Another thing to consider is logging with RDS, MySQL, and MariaDB. So in general, there are a few different logs that we're working with and considering. The general log, the slow query log, for example. With these, you can specify that they're written either to a CSV table or to a CSV file or a table. We want to make sure that when we configure this that we specify the long query time database parameter so that it's sufficiently high that we're only capturing the actual long-running queries. If you set this value too low, then you run the risk of putting an additional burden on your database instance, which is something that you're trying to avoid to begin with. You want to try and avoid large CSV files or tables by using the rotate stored procedures, the rotate general log and rotate slow log. And then, of course, when we're looking at these logs and at logging in general, there is always a performance penalty for logging operations. And so we want to make sure that we're only enabling this if we're specifically trying to identify an issue that needs to be addressed. If you're not looking for a specific performance enhancement, if there's nothing that you're specifically looking for and you're just running under normal operations, you want to make sure that you disable logging. So with regard to MySQL and MariaDB replication tips, one of the things that we can specify is making read replicas writable. When you do this, it's something akin to voiding the warranty on that read replica. In other words, that read replica will no longer explicitly represent what is on the master because you've made changes to it, of course. But in some cases, that's warranted, and that's something that you want to do. So, for example, if you have one of your read replicas is operating as a reporting instance, and you want to add an additional index to it because that index is important for reporting, but it doesn't exist on your master because you don't need it on your master, but you do need it for reporting, then it would be useful to create that on just the read replica. But just be careful about what you do on there because it does obviously change the read replica, and so that it does bring it somewhat out of sync. We do support managed replication chaining. What I mean by this is you have a master, for example, and then you have up to 5 slaves to that master, and then you can daisy chain additional replicas off of those slaves. And so that might be a scenario where you might use that is in a single region you have your master that is taking on read-write traffic, and then you have 1 or more slaves in that region, and then you want to create your DR slave that's in a different region, and that's reading off of one of your slaves that exists within the original region. We currently support 5 read replicas per master, but that's a soft limit, and that's something that we can adjust if that's something that you need. We do support non-managed replication, which is useful for on-premise to RDS or EC2 to RDS scenarios. And for that, we're going to use stored procedures rather than using a service API. And this is something that in the demo that we're going to see in a few minutes, we're actually going to leverage this mechanism. So with any relational database, or any database for that matter, it's important to consider how you're storing the data. And with RDS, you have 3 different storage options. The first is magnetic. Magnetic is very low cost, but it also has very low IOPS and latency can vary. So we don't see a lot of workloads that run on magnetic, but there may be a special case where it may be a good fit. More likely, we see a lot more cases that use general purpose or GP2 disks. These are SSD-based storage that have up to 3,000 IOPS burst capability. The ability to burst depends on an accumulation of burst credits, and so if you have a bursty workload where you're not always hitting the disk and always working the disk and needing a lot of IOPS consistently, then the GP2 might be a good fit. It's worth noting, though, that once you reach a terabyte, since we allocate 3 IOPS per gigabyte, that's the point where you're going to have a guaranteed 3,000 IOPS, and so the burst ceases to become advantageous at that point. And so if you're looking at that, if you need something more than 3,000 IOPS, or if you need consistent IOPS delivered all of the time, you're going to want to take a look at the provisioned IOPS type of storage. This is also SSD based, except you get to specify how many IOPS you want precisely, and then we deliver those IOPS to you on a consistent basis. This is what we usually see for high performance or high-end production workloads, whereas we see the GP2s either for test dev workloads, or if you know your workload well and you know that your workload is spiky and it will still perform well with a spiky type of, the burst ability of the GP2, then we see that sometimes with the GP2. But for almost all of these use cases, we do recommend the SSD-based storage type. So why is the I/O important? That may seem like a silly question, but obviously for reasons of reading from the disk when you're doing queries, but some other scenarios that maybe don't immediately come to mind are crash recovery, engine upgrades, and DDL. All three of these also require a significant amount of database IOPS and throughput, and so you want to consider these three scenarios in addition to your overall general performance when you're selecting the EBS volume that you're going to use on your RDS instance. If you look at the bottom, we're talking about the multi-AZ failovers. And so with a multi-AZ failover, if you have the appropriate storage type and you've effectively eliminated the storage throughput and IOPS as your limiting factor, then it really brings it down to just DNS propagation. And so that can significantly minimize downtime during a failover if you have the appropriate EBS volumes. As I mentioned earlier, the GP2 is a great choice, but once you exceed a terabyte, you can see from the graph on the lower right-hand side of your screen that once we exceed that terabyte point, we don't get any additional burst beyond that. The baseline performance actually exceeds the burst. So for anything less than a terabyte and that requires up to 3,000 IOPS, I would consider the GP2. But otherwise, you're going to want to look at the provisioned IOPS. Another thing to consider is not only the EBS volumes themselves, but also the idea of using an EBS optimized instance type. You want to have an instance that takes advantage of full EBS throughput, and so some of our newer instances natively support that right out of the box. The M4s, the R4s, the C4s, those all have EBS optimized right out of the box. So let's talk about how do we migrate onto RDS. We already have an existing EC2, or maybe we have MySQL that's running on premise, and we want to move it into RDS. How do we do that? Well, one way to do that is with the AWS Database Migration Service. What we see here is that the database migration service can move data. It can move it from MySQL to MySQL, or it could move it from, say, SQL Server or Oracle to MySQL. It can move it from different engines to different engines. What we commonly see is for the homogeneous movements of data, where we're moving same engine to same engine, that we use native backup and recovery tools, which we're going to see in a demo here in a couple of minutes. But if you're going cross-engine and you want to move into MySQL or any of these engines, then you might want to consider using the Database Migration Service, as well as the Schema Conversion tool. The Schema Conversion tool allows you to take an existing schema in an existing commercial engine, for example, or even any other engine, and then take that and analyze it and then generate a report, and then also generate scripts that will allow you to convert your schema from the existing schema into the new schema. So if you were moving from a different engine into MySQL on RDS, for example, you may use the schema conversion tool to convert the schema first, and then use DMS to move the data into RDS MySQL. But if we're going to work with MySQL, say on-premise or on EC2, and we're just going to move it into RDS MySQL, then we would do that using some more native tools. So we're going to do a little demo right now that's going to show you exactly how to migrate. In this case, what we're going to use is an EC2 instance migrating into an RDS instance. But what we do here can still apply for moving from on-premise into RDS as well. Okay, so the first thing we're going to do here is we're going to configure our security groups. Security groups are instance level firewalls where you specify ingress and egress rules. So the first one we're looking at here is the source. And so in this case, I've opened up SSH to the world, which generally you wouldn't do in a production server, but for this purpose, we're doing it for the demo. And we're also opening up the Aurora port for the demo target. And so then we're creating a different one. This one is going to be applied to the MySQL RDS target. So this allows us to have bidirectional communication between our source and our target. The next thing that we're going to do is we're going to launch our RDS instance. So in MySQL, we click select. We'll do dev test to start. Next step, we're going to first select our engine version. In this case, we'll just stick with 5.6.35. This is the instance class. In this case, we're going to pick an R3 large. We don't need to do multi-AZ right away, but we do want to specify the size of our volume and the number of provisioned IOPS we're going to use in this case. I'm going to name the instance. I'm going to give it the master username, which is essentially the root. It's effectively the closest thing to root that you have in RDS, and a password. We'll click next. The next thing is network and security. You can run this in any one of your VPCs. And then we generally make these not publicly accessible. Relational databases usually are not. We're going to put it in availability zone 1A because that's where our source is. And then notice we selected the security group for this RDS instance as the target. Specify the database name, keep some of the default options. We are going to, in this case, enable IAM database authentication. We're going to go ahead and enable encryption. We're going to leave the backup retention period at 7 days, which is the default. Here we want to make sure that we enable enhanced monitoring to take advantage of that. We'll change the granularity down to 1 second. And then we're going to leave the maintenance options the same, just the defaults. We'll go ahead and launch the instance. All right, so it's creating. Now it's backing up. And now the instance is available. So let's connect into our source database. So the first thing we want to do is we want to set up bin logging on the server. So we need to change the MySQL configuration file and add these 2 lines here to enable bin logging. We'll save the file. Now we need to restart the MySQL daemon. All right, so the next thing we're going to do here is we're going to back up the source database. I'm going to specify a single transaction to make sure that we have a transactionally consistent view of the data when we create this backup. And we're going to write this out to the local disk to a backup.sql file. Okay, the backup is now complete. So the next thing that we want to do is we want to connect out to our target database, but we need to know the host name. So how do we do that? For that, we're going to go back to the console. We're going to go to our instance, and right here, the endpoint has the name. So we'll paste that in. We'll remove the port number from it, and now we're going to execute backup.sql on the target. Okay, at this point, the database has been effectively restored on the target. And so the next thing that we're going to do is we're going to connect back to the master. And once we're connected to the master, we're going to create a user named REPL user. And we're going to use this user for bin log replication. So the next thing that we're going to do after that is we're going to grant replication client and replication master permissions to the REPL user. All right, now we'll exit the source. Now we're going to connect back to the target. Oh, before we do that, actually, we need to get the location of the master log file and the master log position. So we have those, we copy them down, and we're going to now connect back to the target. Get the host name again, paste it in, remove the port. All right, so now we're connected to our target. And so now we're going to configure bin log replication on the target. So we need to set the external master. We're going to go ahead and point it to the IP address that is our current source. And you can see that at the top left of my window there. We're going to specify that we're using REPL user in the password. These are the bin log coordinates. All right, so now that we've done that, now the next thing that we need to do is we need to start replication. Okay, and so now that we've done that, we're going to check the slave status. First thing is we see we're waiting for the master to send events, so that's good. The last error number was 0, so that is good, and we're 0 seconds behind the master, so we're in good shape. So let's go ahead and connect to the target. So on the target, we have a database that we just restored that has Major League Baseball player information in it. And so let's look up a player here. So Alexi Amarista, that player exists as that ID on the target. So now we're going to connect back to the master. And let's double check, and it's the same there. So let's go ahead and change that value here on the master. We're going to just give him a new name called new name. And then let's verify the change on the master. It's there. That's great. We're going to connect back to the target. And so we've also verified it on the target as well. So now we're ready for the cutover. So we just stopped RDS replication. And now we're going to reset the external master. And so now at this point, our database has been restored into RDS. We've caught it up with bin log replication, and now we have just cut over, and so our RDS MySQL instance is up and running and is its own master. And at this point, we can change it to become multi-AZ or create read replicas or do whatever else that we want to do because our entire database is now synchronized and up and running in RDS. All right, so now we need to switch back to the slides. So, for additional information on getting started with Amazon RDS for MariaDB, we have a number of links right here. For RDS MySQL, we also have a number of links here. For Amazon Aurora, here are some additional links. And then I just want to say on behalf of myself and Cheyenne, thanks for your time today, and have a great day.